First of all, good morning to everyone, and thank you for the organizer giving me the opportunity to discuss about some of the enhancement in the technology for the AMI or smart metering. And I am Kaveh Razazian, CTO of the Energy and Telecom Sagemcom, and I'm board member of the G3 Alliance. I'm just going to make a short introduction on the G3 Alliance. G3 Alliance, it is established in France with the leadership of the EDF and Enedis. Enedis is the distributor of the 33 million household in France. They were looking for establishing a better technology, PLC technology, for their AMI in 2005, 2006, and they invested with some semiconductor company and system integrator to develop a new technology. And the technology, as we know, is a G3 PLC, is a power line communication, and the solution that they were looking for, it wanted to have higher data rate, longer distance. Reaching to the longer distance, as well as robust communication, IPv6 capabilities, and the most important, standard base. And a standard base means that everyone can have access to the solution, and they enjoy having multi vendors and multi integrator participate in their AMI deployment. And one of the other point that they were looking for the self-healing network, the network can adapt itself based on the condition. And as a result of that, they come up with the G3 PLC, and then they established the G3 PLC Alliance. And there are about 100 system integrator DSOs. Semiconductor companies are participating in this alliance, and they are very active to review the specification and be able to understand, and then to make a necessary modification to adopt the various needs of the market and various issues that the market is facing. As a result of that, there is about 80 million of the nodes are being managed by the G3 PLC. Communication is a PLC as a whole, and in addition to that, there are almost about 500 manufacturers certify the solution. And G3 Alliance, the main responsibility is the guardian of the solution. Guardian means that it creates an environment that all these system integrators, semiconductor, they can work together to define the solution. They make the specification, and then they move the specification to the ITU, international certification body. And over there, it becomes certified for global use. And in addition to that, they are responsible for the certification part of it, making sure that the product the vendors are using is certified and interoperable. Having said that, based on the introduction I made, I wanted to introduce the latest work that the G3 Alliance has done and introduced about a year ago, is a hybrid G3 PLC RF. Now, why they got to this road, and why they decided to add the RF technology to the G3 PLC? That's actually the evolution of the smart grid. You know, a smart grid started in 2009, 2010. The needs are being reevaluated. And what are the needs that we are talking about? Originally, when they wanted to develop the AMI, mainly was the meter reading and certain tempering detection. and demand response, limited demand response. But today, the market is looking at the transition from AMI to a smart grid application. And when we talk about the smart grid, it means that battery powered devices. In addition to that, the expectation for when they talk about the KPI and expectation to the KPI, what is the performance of device? At the beginning, they were expecting a 95% KPI, 96%, 94% was the right number for the DSO to manage their network. Today, they are asking for 98, 99% KPI. They wanted to have the better performance on the communication link. As you know that when we are talking about communication link and why we are spending so much time on the communication link, because it's the first building block of the entire network. When you wanted to make your AMI network and you put all the software, smart applications on top of it, first you have to have the link and reliable link to be able to pass the information. As a result of that, the communication become very important, and we realize that in order to move to the next phase of it, by keeping the RF technology inside the PLC, it creates more flexibility in the solution, increase the reachability, a lower cost of the ownership. It means that the infrastructure that you have to build for either technology is reduced, putting the repeater canopy, all those, because the complementary solution automatically be able to manage each other, means that the device has the intelligent automatically switch to the RF or PLC communication. And when we come to the performance, as I said, that it is a bridge to take you from the AMI market or a smart metering to a smart grid application, IoT application, as well as the gas meter, water meter, you can include it to your network. And that was the merit of introducing this new technology, which is the PLC hybrid. Just to emphasize the point of the hybrid, because there were some miscommunication in the market of the hybrid. They think that it is a module-based solution where the meter, you can change the module, you can take the RF module, you put the PLC module. It is not the case. It is a single solution, and a single microprocessor has the intelligence to make the determination that whether it use the RF or whether you use the PLC based on the channel condition. Just wanted to emphasize on this topic because there was certain misunderstanding on how the hybrid technology is operating. The next point, as I said, that the use case about the transition to a smart grid, that was one of the points. The other point was about reachability. I said flexibility and reachability. Why we concerned about reachability? Because this new solution, it does some use cases that before we have to build the infrastructure, we have to put a repeater. For instance, in this case, you can see that we have an isolated area where it cannot be connected to the data collector, which is the data concentrator, DCU. It cannot, and normally you are putting the repeater or a secondary DCU and a different scheme, or on the RF, in RF case, you are putting the canopy and the repeater. But in this case, you can use the RF technology to connect the PLC network. And the other point here is that the other use case is that when you have a low density and high density network, there are cases that in the low density network with the 5 or 10 meters, you may have to put a data collector, and it is very costly. But with the RF technology, you can make a bridge from a low density network to the high density network and use the single data concentrator, reducing your capex on this deployment. And the other thing is that when you have this type of solution, which is a private network, your OPEX cost is reduced a lot. Means that you don't have that much of the OPEX. You're putting on the CapEx investment, and and you can have a scheme to reduce the cost of the capex. And having said that, I just wanted to share with you just the last part of the presentation. In the partnership of G3 Alliance, ISGF, ST Micro, and the local DSO, we have done a proof of concept in India, and I can show you the location that we install is a small POC, and there are certain unique significance about this deployment is that, first of all, the area is very noisy. You can see that I just put the blue line means the PLC signal, the red line is the noise. You see they are reaching each other. It's a very harsh environment for the PLC to communicate. In this case, if you wanted to use the fully PLC, you have to build the infrastructure. We have to put the repeaters and certain way to increase the transmit power so that you'll be able to achieve the 100% KPI. And then it was very unique area because when we are looking at the RF aspect of the solution, the interesting was that the houses was facing in the opposite direction. And if you're looking at the DCU, you can see that the front row houses are easily can communicate with the data concentrator, which has an RF capability. But the back building, the RF signal was going in the opposite direction. And it is much difficult for the back building to be able to communicate to the data concentrator. And there is a weakness between the two buildings. Again, in the RF technology, we have to put the repeater so that we can improve, or we put another gateway in the direction of the RF signal so that we can collect the information from the building in the hall.
Sir, sorry to interrupt you, but we are running out of time. So if you can speed it up.
Yeah, I have maybe a minute to finish it up.
Thank you.
Yeah, I just want to say that at the end is that by combination of the RF and PLC technology, you can see that the yellow lines are the RF technologies, and the red lines is the PLC. You can see that the back buildings using the PLC communication to reach to the DCO means that the back building with the RF technology now can reach to the data concentrator through the PLC, and many areas with a high noise that the PLC cannot operate and the RF can operate. And the other thing is that you can see that during the day, the network keeps changing. You can see that here we have 3 PLC links. At night, we have 1 PLC link, and mostly is RF. Means that it's adaptive to the network and it changes. And then in addition to that, it's complementary to each other. I'm going to conclude it. I conclude my presentation by saying that this is a new way to improve the reachability. Is a standard-based, interoperable based, and offers a new application and a new avenue to enter to the smart grid arena. Thank you very much for the opportunity.